Hi, the section 3i, the varying interest. So far that we consider the cases that the interest rate is constant over time. So we only think about just one I, but here that we think about the cases that the interest rate changes at some points. Okay, so example. So 5 deposits of $100 each are made at the beginning of each year. The I is the annual effective interest rate, is 3% for the first 3 years and 5% in the following 2 years. And calculate accumulated value the 5 years from now. So t is equal to 5. So what is the timeline? The timeline, we have t is equal to 0 to 5. And we have 5 payments. The first one at time 0. Second one at time 1. And the third one, fourth one, and fifth one. And interest rate is 3% for the first 3 years. So here, and then in the following 2 years, 5%. And we would like to calculate accumulated value here. So the point is that since the interest rate changes, they evaluate the value at each time point when interest rate changes. So here, the key is t is equal to 3. So we have maybe the 3 payments. Okay, so these payments, okay, so it accumulates the interest at 3% until t is equal to 3. So we consider the accumulated value of this amount. Then we think about another sequence of payment. Then we add accumulated value of this one and the accumulated value of x. So in this way, we would like to calculate it. So evaluate the value at each time point when interest rate changes. So here, the only one point at which interest rate changes. So we calculate the value at 3 at first. Then after that, we think about the value at time 5. Okay, so accumulated value at time 5, that is usually denoted as A of 5. So this is accumulated value for these first 3 payments plus accumulated value for last 2 payments. And the accumulated value for the first one, so that is equal to, if we use this x, the x times 5% and for 2 years. So 1.05 square times x. And the second one is the accumulated value for the following 2 payments. So this is y. So we would like to calculate this. And what is x? X is the annuity due, the accumulated value of annuity due. So that is S double dot right angle 3, since we have 3 payments at 3%. Then we have $100 each, so 100 times this. And y is the 2 payments, the accumulated value of 2 payments. This is also annuity due. So 100 times S double dot 2 right angle at 5%. So what's the first quantity? This is 1.05 square times 100 and times actually the 1.03 times S right angle 3 at 3% plus 100 times 1.05 times S right angle 2 at 5%. So basically the double dot is 1 year later than, no double dot. So that means if we have double dots, we have to multiply the 1 year of interest. So for the first 3 years, that is 1.03. In the last 2 years, that is 1.05. So now that we can calculate it, you can either use the calculator, BA2 plus, to calculate this, or you can use the formula for this. So if you use the formula, this becomes 1.05 square times 100 times 1.03 times 1 plus I, so 1 plus 0.03 cube, because we have the 3 payments, minus 1 over I, so 0.03. Yeah, and the last 2 payments, so last 2 payments is 100 times 1.05 times 1 plus 0.03 square minus 1. Oh, sorry, the 0.05 square divided by 0.05. So this becomes 1.05 square times 318.36. This is the x value. This is x. And plus 100 times, yeah, so this amount, so this is 215.15. So in total, this becomes $566.24. Yeah, so in this way, we can calculate this. And I would like to also mention that these quantities, S right angle 3, the times some constant, that this can be obtained by a calculator at once. So immediately you can come from here to here. And also you can calculate this quantity by just BA2 plus. Yeah, you can also include 1.05 square if you want. So this is the example for the varying interest.